In this nugget, we'll be addressing how to configure local storage. We'll take a look, first of all, at basic disks, which is something you've probably worked with for a long time. There's also the dynamic disks, which have been available in most recent versions of Windows. And with these, you can also create dynamic volumes. We'll take a look at the advantages of those. And we'll also address the various file systems that are out there. You've probably heard of FAT file system, FAT32. There's also NTFS, which is highly recommended. And now the new resilient file system, which gives you all of NTFS plus more. We'll take a look here also at creating your own VHD files, which makes things very portable and easy to work with. And we'll also take a look at how to mount VHD files in the interface for disk management. We'll take a look here at storage spaces. This is probably the most powerful feature relating to storage that Windows Server 2012 offers us. There's parts of this that are also available in Windows 8, but what I'll show you here is how to work with this space, and then you'll see that it's very, very flexible and gives you a great deal of recoverability as well. Wow, I'm glad I got out of there. I just left Starbucks, and I'm usually there every morning, checking email, getting my day started, planning out what I'm going to be doing, and things like this. And I decided to leave before a certain time of the day. And this is because at a certain time, I don't mean to sound unkind, but there's an elderly woman that comes in who's actually very energetic, and she's got this wild frizzy hair, and she has this deep German accent. Well, for some strange reason, she thinks it's really funny to sneak up on people in Starbucks and to scare them. Well, I don't want that to happen to me. I don't want to be taking a sip of my coffee and have someone startle me and have me spill it all over the place or something like that. I can do that fine on my own. So I usually actually sit in the corner so that she can't sneak up behind me. Now, I don't want to exaggerate it. She doesn't do it every day and to everybody, but it happens apparently often enough that I just don't want to be unsettled by that. So I made a quick getaway today when I thought she would be coming in at a certain time. Well, anyway, it's just kind of creepy. Well, another thing that's really scary is if you were to run out of storage space. Yeah, I know. Really awkward segue, isn't it? Well, let's take a look, though, at the kinds of storage that we can work with, and you're probably very familiar with some of these. We're starting off here, though, with the basic disk. Now, as we take a look at this is something that you probably have worked with before because it's just the default disk type. It's pretty much the same kind of thing we've done since the days of DOS. I remember back in the 80s, I think it was the 80s. Yeah, late 80s, I bought my first hard drive. It was a 20 megabyte Seagate. All my friends said I was a fool because I'd never use half that space. But anyway, I created a basic disk when I just partitioned the drive and formatted the drive. That was it. So it's a default disk type, which you've had for a long time. One of the advantages of it, though, is it's very widely compatible. So I could take that disk and I could plug it into other operating systems. If it was, for example, an external disk that I had formatted as a basic disk, I could plug it into a Linux operating system. I could plug it into a Mac OS. I could plug it into a lot of different things. Just about anything can read a basic disk, depending on what the file system is as well. It still has to have a readable file system, which we'll cover also. It's also very easily accessible. So, for example, if you have a basic disk on a multipath SAN, a lot of SAN networks, we just kind of just a vague area of storage where you have a whole bunch of storage disks. It kind of looks ghoulish or like Swiss cheese or something like that. But anyway, so you have all these disks in a SAN, and there's a lot of different ways to gain access to them, kind of like there's a lot of different network paths to a router. It's really a little oversimplified, but the point here is when you have a basic disk, it's easily accessible, whereas we'll take a look at a dynamic disk. A dynamic disk in a SAN would not be so easily accessible, and it could cause you some problems. When you have a basic disk, you can have up to 4 primary partitions, or you can have less than 4, which is 1, 2, or 3, and an extended partition with a logical drive. Now, if you try to work with disk management in Windows, what will happen is on a single drive, if you try to create 4 primary partitions, the last one, it won't let you create the 4th primary partition. You could do that through command line methods, but using the UI, it won't let you do that. When you create the first 3 as primary, and then you try to create the 4th one, it'll create it as an extended drive with a logical drive in it. Extended partition with a logical drive. And this is also a function of whether or not using a master boot record type of a disk or a GUID partition table type of a disk. This assumes MBR because that's what we work with there. Now, there's also no fault tolerance, though, with a basic disk. So that's a little bit of an issue because it's really only useful for kind of one-off storage installations where you just need some quick and dirty storage over here, and you just plug a drive in or something like that. Doesn't really have any advantages in terms of fault tolerance. In other words, you can't do things like RAID, RAID 1, RAID 5, any of that kind of stuff. We'll talk more about RAID here in a minute. Now, you can have fault tolerance with a basic disk if you're using a RAID controller. Okay, so if I have a RAID controller in my hard drive, it might have, let's just say, 3 hard drives all connected to this RAID controller on my computer. This is going to be presented to Windows as a single drive. It's going to look like a single larger drive, and it's going to make all this storage space available for me. So I might format that as a basic disk and just start writing files to it. Again, on my side, it looks like a single drive. Really, through the controller, it could be RAID, which is a redundant array of inexpensive disks, and is often used for improved performance and or improved fault tolerance. Alright, so how do we actually make this work then? Well, you can use computer management to work with these disks, both basic and dynamic disks, which we'll talk about next. But you can see here, first of all, that we've got a couple of partitions. Here's the system reserved one, which notice it doesn't have a drive letter. This is what's used to boot the operating system, but it's called the system drive. Okay, it's the active primary partition. The active drive is the one that has to be booted from, and it has to also be the primary partition here in Windows. Now, this is where the operating system files are located, but it's called the boot drive. Go figure. I don't know why Microsoft does that, other than to make it as confusing as possible. So, in other words, again, the system drive has the boot files. The boot drive has the system files. Anyway, let's go down here to the disks. Notice that I've put 4 disks in. These are all actually just in Hyper-V. They're virtual disks that I've kind of plugged in here, but they work the same as if I were to have physical disks. Notice that as I put them in, they're all unknown because they're all offline as well. In order to work with these, I have to bring them online with a right click here, and then also notice that they're not initialized. I am unable to create any kind of a volume over here until I've also initialized the disk, which puts some uniqueness information on the disk that Windows can identify. Notice that also I have the option here to make it an MBR, Master Boot Records partition style, or a GUID partition style. Now, look at the size of the disk. It's only 127 gigabytes, which is kind of small by today's standards. I'll discuss the differences between these more coming up, but for the time being, I'm just going to use an MBR because it's not over 2 terabytes in size. Then what I would want to do is to create a basic disk. Notice that as I right-click here now, I choose Simple Volume as an available item. These others are grayed out or unavailable because it's not a dynamic disk, which we'll again talk about shortly. But once I get this started with the wizard, I'll just specify the size. I'm going to make it 100 megabytes to make it small and format quickly. And then I'm going to assign it drive letter E. I'm going to show you this other option here in coming up shortly here when I create another partition. Then I'm going to click on Next, and I can say Format the volume with the following settings. And I'll just call this, let's call it simple, because it's a simple volume. Otherwise, normally you'd call it something that makes sense, SQL data, whatever, user file, something like that. I'm going to make it a quick format, and I could also choose to enable file and folder compression, which will give me supposedly up to a 2-to-1 storage ratio. Okay, so then I'll go ahead and click on Next and click on Finish. Now, once that's been done, you can see that it formats pretty quickly here. And this is kind of weird. It also gives me this blinking Explorer thing down here. Why? Because it asks me to format a disk that I already formatted. Thank you very little. I'm going to click on Cancel. So there's my partition. Now I can explore this, and you can see that it's now available to create new folders. And once I get a folder, I could create files and so on. Pretty simple storage, pretty easy to work with. Now, as we return to this, let's take another look at this. 100 megabytes isn't very much space. Let's say I made a mistake, and I meant to give it 200 more megabytes. Still not very much, but I'm kind of stingy. So I could say, hey, I didn't give it enough space, but I've got all this space over here to the right that I can use. So now I can choose to extend the volume, and I'm going to extend it however much I decide I want to. So let's just say another 200 megabytes, which should give me a total of 300 megabytes right here, and it's just that simple. As long as there's unallocated space to the right, you can extend the size. Likewise, I could also shrink it if I wanted to. And I could shrink it here, and I could say, let's shrink it by 200 megabytes. And I could make it go back down to 100. So very, very easy to work with that. But again, to expand it, I have to make sure that there's space over to the right. For some reason, it doesn't allow me to expand it if there's space only to the left. This car only makes right turns, apparently. It's like my 95-year-old mother when she drives the car. Yes, she drives, people, and has the right turn signal on constantly. Now, the other thing I could do with this is, let's just say that I'm going to quickly extend this all the way to the end here, and then we'll just say, uh-oh, you know what? We ran out of space completely. So we filled up all 127 gigabytes, and now I don't have anywhere else to go. So quickly, we ran down to the electronics store, we got ourselves another drive, which I've already brought online and initialized, and now I want to make this space available to drive E. The thing is, though, if I go into my drive E right now, which is the simple drive we have right here, I have some user files in there. It's actually an empty folder. But let's just say that I wanted to make this easily available to my users. Well, one thing I don't want to do is to create a whole new share for my users. Maybe they're already accessing this shared resource. Even locally, I don't want to have to flip back and forth between this drive letter and this drive letter and so on. So what I could do here is I could make this new simple volume available to that empty folder. That way, all I have to do is to go to drive E and then double click on the folder. In reality, what it's going to do, it's going to take me to this drive, but it'll be transparent to me. It'll also be transparent to any users that are accessing it through a share. So I'm going to go ahead and actually, let me make that small again. Give ourselves another 200 megabytes here. And now I'm going to either assign it a drive letter, or I can mount it to an empty NTFS folder. And I'm going to mount it to this empty NTFS folder of user files. If I don't have an empty one, I can create a new one. Then I'll click OK, and then I'll go ahead and click on Next. Okay. Then I'll just call this, mounted, for lack of anything more creative. Click on Next and Finish. Now, once that's been done, it's telling me here that it doesn't have a drive letter. I'm okay with that for the time being because I don't really want it to have one. I'm not supposed to just double click on this and access it. What I'm supposed to do is to go to drive E, where there's user files, double click on that, and now here I can create my folders and files. Okay, I'll create another folder, and I'm just trying to get to a file here. So create a file. There we go. Okay, so where is this actually created? This was actually created on this storage right here. It's not stored on drive E, even though it tells me that it is. Okay, so that just makes it a simpler path to be able to access, and again, prevents me having to create a separate share for this new drive. Now let's move on here to a dynamic disk. This is really just a marketing term that Microsoft came up with. Dynamic does not mean that it's any faster than a basic disk, at least not on a fundamental level. So there's no direct performance benefit here whatsoever. And when you work with dynamic disks, you don't have partitions, you have volumes. Partitions go with basic disks, volumes go with dynamic disks, but colloquially speaking, we use the two terms interchangeably, so it doesn't really matter conversationally speaking. This does allow for multi-disk configurations, although you could have a simple dynamic disk, which only needs one disk. But these other ones would be multiple disks. So, for example, a spanned disk. This would be useful if I have a disk right here, and we start to use it, and it fills up with space, and pretty soon we realize we're going to run out of space, and we're going to exhaust our spanned disk. This is what I call spandex. Just kidding, folks. That was a horrible joke. Anyway, so it starts to fill up, so we anticipate that, and we put another disk on here. We make it a spanned disk so that when this disk fills up, it spills over to this disk, and it starts to fill up as well. That's a spanned disk. But if one of these fails, I lose all the data. So there's no failover or redundancy in any of that. Now, there's also a striped disk. This would be known as RAID 0. With this, what happens is we have 2 or more disks, however many fit in the cabinet, really. Same with span, it's really just however many disks you have space for, I'm just writing into. And with this one, we have data that's written to the disk, but let's say I have a file that's 123.txt. Okay, with striped, part of it's written up here, 1, and then maybe 2 and 3. .txt is written down here. So the data is written in a stripe across all of the available disks in this configuration. If I lose one of the disks, then the remaining disks have no meaningful data on them. So there's no failover with that. There's also mirrored disks, which we generally have only 2 disks involved in that one, although you'll see later on that there's a new method where you can actually use 3. But anyway, I have a mirror. What takes place here is, again have my 123.txt file. And what happens here is when I first create that file, it writes to both of these disks simultaneously. And when I read from the file to open up the file, it could open from both of these disks simultaneously, especially if it's a large file. I could get a performance increase. Okay, so we get a good performance with mirroring. because we can use both disks at once to read and write data. We get the same benefit, by the way, with Striped because we can read and write to both disks simultaneously. It's just that with Striped, we have no failover. With a mirror, we do. Because look, if this disk fails, this disk is still available and still has a full copy of that file. And then we can also work with a striped set with parity, also known as RAID 5. With this, you need to have at least 3 disks. And what would happen here is we would have our file being written 123.txt, and it would be partially written to this disk and partially written to that disk, and then so the file would be contained on these 2 disks. But then we would also have parity data, which is mathematical calculations that would allow that data to be reconstructed if one of the other disks were to fail. So if this disk were to fail in the future after this file had been written and the parity data had been constructed, then using this disk and the parity data, the file could be reconstructed. It'll be reconstructed when someone tries to open that file, even though this drive has failed. It'll also be reconstructed on rebuild when we replace that disk with a good one. It'll still use the parity data to replace the data again on that disk. Now, the parity data is kind of done in a round-robin fashion. It's not always on this one disk. Some of the older methods of writing parity data used a dedicated disk for that, but we don't see that very often anymore. With Windows and dynamic disks, it scatters it around. So today, for this write, it'll be on this disk. Next time it writes data, it'll be on this disk. Next time it writes data, it'll be on that disk, and it kind of shares the load. Now, I do want to point out that most administrators don't use all of this stuff for dynamic disks, especially for medium and larger organizations, where instead they'll be using a SAN, some kind of a cloud storage, or they'll be using a RAID card with a big cabinet full of drives, and they won't be using the Microsoft method here. It's a little bit more proprietary to use this dynamic disk. Only Microsoft operating systems can really directly read these disks. Whereas using something like a RAID cabinet, you might have multiple operating systems that can all access it and have industry standard methods for being able to recover the data and stuff like that. So a lot of administrators don't use this. Another reason why a lot of administrators don't use dynamic disks is because RAID 10 is not available. RAID 10 works like this. You'll actually have 4 disks, and what will happen here is we'll mirror the data. So we'll have the data written here, have the data written here, and then it's actually also striped across these 2 disks. What happens then is we can actually sustain the failure of more than one disk. So for example, if this disk were to fail and this disk were to fail, we still have a full copy of our data. In fact, even if all 3 of these disks were to fail, we still have a full copy of our data. So RAID 10 really gives you a pretty good redundancy there and ability to recover the data even in the event that more than one disk fails. But that's not really part of the exam per se. All right, let's take a look at how to work with these dynamic volumes. Now, I've already deleted what I already had previously created here, so now I want to create a new, let's go with a spanned volume, spanned volume. We'll click on Next, and I'll just add in, let's just add all of these in, just because we want to be big here, all right? So we're going to add all of those volumes. Then I'm going to go ahead and click on Next, and I'll give it a drive letter, and we'll format the volume. By the way, notice that we don't have the FAT file system here anymore. I'll talk to you more about FAT and NTFS, and this one here, the resilient file system, which is very cool, and which I think I'm probably going to be using a lot in the future. Let's call this one again a spanned volume, and perform a quick format and click on Next and then Finish. And that's pretty much all there is to it, except that you have to click on Yes here because it's telling me that I'm trying to create something that I need a dynamic disk for, but I've got basic disks. So do I want to convert them? Well, yes, because I kind of have to. And then you see that these get converted to dynamic disks, and shortly here we'll see purple, there they are, purple disks here that will be formatted as our spanned volume, and now it looks like they've all come up. Next thing I want to do is to create a striped volume. You need at least 2 disks to create a striped volume. So I'll click on Next here and just add another one in. We'll click on Next, sign in a drive letter E. I'll call this striped. And really, this is all pretty well the same no matter what you do next. Really, all the remaining steps are the same regardless of what kind of a volume that you create. Remember that if I wanted to create a mirror, for example, then I have to have 2 disks. If I want to create a stripe, I can have at least 2 disks. And if I want to create a RAID 5 volume, in other words, a stripe set with parity, I need at least 3 disks, okay? But otherwise, the wizards are going to be pretty much the same. Just depends on what your first choice is as soon as you right-click here, whichever one you make. Alright, now here I want to talk to you about the various file systems. This is not really something that appears on the exam objectives directly, so I'm not going to spend a lot of time on this, despite the fact that I got a whole bunch of verbiage on this whiteboard. The first kind of a file system you might work with would be the FAT or FAT32 file system. This is probably what you've worked with if you've been in computing for a long time. I worked with FAT originally. Actually, there was a FAT12, which we used on floppy disks way back in the day. And then DOS was FAT and a lot of the earlier Microsoft operating systems. This stands for File Allocation Table, by the way. Then we had FAT32, which gives us a little bit more capacity. And then we had exFAT, which is primarily used for thumb drives. And the thing here is you don't really have any security with any of these FAT methods. Okay, they're just very simple, but the advantage of them is they're widely compatible. You can plug them into just about any operating system, and that operating system will be able to read the disks. So they're very unsophisticated, but widely compatible. There's also NTFS, which is definitely the most broadly used file system now. The thing we have with this is the ability to assign security permissions through an access control list or an ACL. That's where I can determine that HR employees and members of that security group are allowed to access this, and members of the, sales department are explicitly denied permission to access this folder. Well, that's because we have security permissions. We'll talk again more about that as we go on here in this series. There's also encryption that you can apply to an NTFS file or folder, and this means that using certificates it's going to encrypt that file, and then no one else would be able to read it. You can also use compression, and these are mutually exclusive. You cannot both encrypt and compress a file or a folder. You have to pick one or the other. But at least this would give me, relatively speaking, up to a 2-to-1 compression ratio. Using NTFS, I can also use auditing so that I can see who accessed a certain file and when they accessed it and what they tried to do to it, all that sort of thing. I can also assign quotas, which is an important topic that we'll be discussing as well throughout this series here coming up. Quotas make sure that people can only use up so much space on a given drive or in a given folder. There's file tagging, which is also useful for certain file operations that we have starting with Windows Server 2008 R2, and allows different files to be automatically categorized or stored in alternate locations based on what their tags are. A very handy feature that we can work with there. There's also very large files and large volumes that we have, whereas with FAT32, for example, you had a maximum of partitions that could go up to only 2 terabytes in size, so that wasn't really very large. Now, the resilient file system is really probably where the future of file systems will go. A couple of reasons for this. This is called, by the way, the resilient file system. This gives us access to even larger files than what we had before. Well, with this, you can get a single file up to 16 exabytes in size, people. It gives us a lot of other things as well, which I don't know if we'll ever use them. But, for example, the file name length, you could go up to 32,000 Unicode characters. I thought some of my file names were long. Well, now we could really get long with the resilient file system. Same with the maximum path length, up to 32,000 paths. The maximum size of any storage pool, we'll talk about storage pools coming up as well here, 4 petabytes. So you can see we can work with really large items right here, large directories, large volumes, and so on. It gives very high resiliency as well. There's built-in error correction and verification. Sure, NTFS also had some of that, but it's just not as good as the resilient file system. It has, for example, metadata integrity with the checksums, just to confirm that the data hasn't been corrupt. It has all kinds of things built into it now. For example, there's also disk scrubbing for protection against latent disk errors. It just does all kinds of things that are really cool there. Again, not part of the exam per se, but something that I think you might want to know about. It's also backward compatible. So maybe I've got a Windows XP system out there, and it's trying to read a drive that was an REFS file system. It'll still be able to read it just as if it were NTFS. So that's a really big selling point for REFS, is that you're not going to give anything up by going to REFS, and you get a lot of the new additional features. We also have the various partition types over here. One of the first ones was an MBR disk. Remember when we were creating our volumes here a moment ago that it asked if we wanted to create a GPT or an MBR type of a disk partition table? Well, an MBR is the traditional partition table that we've worked with for years and years, but it only goes up to a maximum of 2 terabytes. A GPT disk will give you up to 128 partitions, so pretty expandable there, and a partition size up to 8 zettabytes. Wow. That's again just a huge size. A hard drive can be up to 18 exabytes in size. So these are really pretty staggering storage amounts that you can work with there. You can also do this. This is not really part of the file system. This is really in its own category here. But you also need to know how to create and mount VHDs and VHDXs. Let me talk to you a little bit about that. One of the reasons why you would want to do that, first of all, is that you might want to create kind of a portable drive. If I make available to an operating system an entire hard drive, maybe it's a physical drive, I have to plug it into a SCSI cable, or I have to plug it into a SATA connection, something like that, right? Then if I want to take it somewhere else, I've got to unplug it, physically transport that drive somewhere else, and plug it in elsewhere. Well, with a VHD, I can make that appear as if it's an actual physical drive, and then if I want to move it somewhere else, I can just copy it over the network, for example. So it's much more portable and easy to work with. Also, I can mount a VHD. What if I've got a Hyper-V guest that doesn't have all the files it needs, or I need to remove some files from a guest? Well, I can add or subtract files by mounting the VHD or VHDX. Let's go ahead and take a look at how we can work with that. Alright, so how do we actually work with these VHDs? What we can do is to go to Disk Management, to right-click, and then choose to create a VHD. If I wanted something like, a portable VHD that I could drag around or something like that. Let's call this one, I don't know, my VHD, because I'm thinking of really creative terms today. So we'll save that one, and then we'll make it a VHD or a VHDX. Again, I like VHDXs. We'll give it a size of, let's make it 20 megabytes, the size of my first Seagate hard drive. And then you can, of course, go to gigabytes or terabytes, make it a fixed size or dynamically expanding, which, of course, means that it starts at 20, but it will grow, if it needs to, up to the amount of available physical disk space that we have. And it should be in here somewhere. Oh, I got to scroll down for it, I think. There we go. So now it's not initialized, so I need to initialize the disk, and then I need to also specify whether it's going to be an MBR or a GPT. It's too small for a GPT, so I'll just leave it at MBR. And then now we see that it has come online. The next thing I can do is I can just create a simple volume here. And I'll just call this, oops, I got to put in a volume type of character here. And then 17 megabytes is all it's going to take because of the formatting. It's going to lose a little bit of overhead. And then I'm going to go ahead and click on Next. And I'll just call this, my tiny drive. Okay, and then we'll go ahead and next and finish. That's pretty much it. Now I have a drive that's available for me. It's really not really good for much because it's so small, but at least there it is. If I wanted to transport it to somebody else, I would just take this offline, and then I could even detach it as well. Okay, detach the VHD. Okay, and then I would just be able to go to the file system. Again, it gives me that crazy message, which I don't really need. Then I could go to my file system here, to my documents, and there's my VHD. I could copy that, put it on a network drive, put it on a thumb drive, move it somewhere else, anything else that I wanted to do like that. Now, the other thing I might be able to do, this is very handy, is to be able to work with existing VHDs that are guest operating systems. All right, so in order to work with existing VHDs, here I've got my Hyper-V Manager. I'm just showing you the machines that I've got up here. First of all, it has to be something that's not running, so I can't do it on my domain controller. Got a couple of DNS servers. This does have to be done on something without snapshots. Okay, so here, for example, this one has snapshots. I could actually mount the VHD and start to fiddle with it, but what will happen is it will corrupt the virtual machine. And they'll have to spend all Saturday afternoon restoring from backup. Don't ask me how I know about that. It came to me in a vision. Okay, just accept that answer, please. Anyway, so what I'm going to do here is I want to mount the VHD that belongs to Win8 Client 01. So I'm going to go over here to, where am I at here? Go to this Disk Management, and I'll right-click to attach the VHD from the Windows 8 client. Okay, that's Windows 8 Enterprise. And I'll click on Open and OK. Notice that I could have also made it read-only. There was a checkbox there to make it read-only. If I just wanted to examine it, but I wanted to protect myself from accidentally messing the thing up somehow. Okay, lesson learned. Anyway, so now what I could do is I can right-click on this once it's been mounted and explore it. And I can say, hey, you know what? This doesn't have enough folders. I need to add another folder. Let's call this one, James Crazy Folder. Okay, make it real easy to see and obvious. So we created that. Now once that's been done, I can say I have mission accomplished, and I will detach the VHD. Yes, it's that one, which means that it's actually going to write the change to that VHD file. Now when I go over here to my Windows 8 client, I can start this up. In a moment, we'll see that the folder is now there. So now I've started up that Windows 8 computer. Let's go ahead and go to Windows Explorer, see if it gives us the folder that we expect to see. So we go to the computer and to the C drive. Come on, there we go. And sure enough, we have James Crazy folder, okay? So mission accomplished. A pretty cool way of being able to work with these VHDs. Here I want to talk about something called storage spaces. Now, of course, each new version of Windows includes some new whiz-bang feature that's the next big thing. I think this might actually be one of the coolest features of Windows Server through 2012. By the way, you also actually have this in Windows 8. Yeah, so you can actually do the same thing that I'm going to show you here in Windows 8. I call this a poor man's SAN, and why would I refer to it that way? Well, obviously, SAN solutions, even smaller ones, are substantially more expensive than just conventional storage. Also, many organizations have full-time staff people that do nothing more than manage the SAN because it's not something that you can really understand or kind of study in your spare time. You really usually have to be good at this. And so you might need to make a full-time vocation out of just managing the SAN. A lot of the things that you'll do are command line only, even though there's web pages that the vendor may have or various programs and things, different ways of managing that SAN. A lot of people who are really good at it just do everything from the command line, and most other people who look at what they're doing would have no earthly idea what they're typing in there. So this is something that makes kind of a SAN-like environment easier for us to manage because those SANs are very expensive and require a high level of expertise. As I said, also, it's available for both Windows Server 2012 and Windows 8. So you can have the same interface in 8 and do the same thing I'm about to show you. What this works with, actually, it's several different components. First of all, you have to, of course, have a physical disk somewhere. But once you've got a physical disk, then you'll be able to create what we call a storage pool, and from the storage pool you can create some virtual disks. So there's all different moving parts in this, and we'll start here with virtual disks. Now the virtual disk, in terms of terminology, we don't want to be confusing about this. These are not virtual hard disks. They're virtual disks. A virtual hard disk would be a VHD, like a VMware. I am bound and determined to lose my Microsoft certification. Like a Hyper-V VHD or a Hyper-V VHDX. Those are virtual hard disks. Virtual disks are part of storage spaces. Okay. What you do is you form a virtual disk from storage pools. Now, that brings up the next question. What is a storage pool? A storage pool is one or more physical disks, and these can be any kind of disk, anything but maybe a thumb drive, although solid-state drives do and hybrid drives would work. This would be something like an internal disk that's already in your computer or that you plug in, an external hard drive that's a USB or an external serial ATA, FireWire, various interfaces. It doesn't matter which one you use. You can mix and match. You can have a couple of USB 2.0, a couple of USB 3.0, an eSATA drive. You can mix all of those into the same storage pool and create virtual disks from them. You can easily extend the storage pool that you currently have with more unformatted disks, and that's important. And I would remember this: they have to be unformatted disks. There cannot be any data on them. So if you're ever in a cold room somewhere, trying to think all of this kind of stuff through, you might want to be aware of the fact that the disks do have to be unformatted. Also, this can be fault tolerant, and that's one of the advantages of storage spaces. You might say, well, James, don't we already have that? I mean, you showed us how to do mirroring earlier and a stripe set with parity or a RAID 5 disks earlier with just using disk management. So how is this different? Well, this will heal itself if a problem comes up. I'll show you how to do that. You can do things like include hot spares, for example. There's a lot of advantages here. And for the future, I would probably move in the direction of storage spaces instead of using disk management. These can also be thin provisioned. This means that you can use just-in-time storage, meaning that just the way we can have expandable Hyper-V guests, where their storage space might start off at, 10 gigabytes, it'll grow as it's needed. Well, that's what the same thing is here. Thin provisioning means that we start with just the minimum amount of space we need, but we will allow it to grow as necessary. Now, once you have your storage pool, you're able to create virtual disk configurations. With this, you need to determine what storage layout you want, and we have a few choices there, starting with simple, which has no kind of failover or anything. There's no, it has data striping, but there's no redundancy of any kind. There's also a 2- or 3-way mirror, and you might have read some kind of misleading data about that. I've even read that in some Microsoft stuff, where it says that for a 2-way mirror, which you're already familiar with, it says you need 3 disks. For a 3-way mirror, you need 5 disks. That's only really true in a clustering situation. In a conventional mirroring situation, like we might be using, you need only 2 or 3 disks, respectively, for that. There's also parity, which of course means that it's going to stripe information across multiple physical drives. But with parity, it's going to also rotate parity data across all of the available disks so that you have some failover there. Also, there's provisioning. You can use fixed provisioning. So if you determine that the virtual disk is going to be 100 gigabytes, then that's all it ever is. And if you fill it up, you'll have to figure something else out. But there's also thin provisioning, where you might have, let's say 200 gigabytes available, but you start off with a thin provision of only 50 gigabytes. And it can grow up to 200 gigabytes if you wanted to. Or up to whatever the available physical space is. There's also the allocation. You can decide to make it a data store. Once it's a data store, it's going to actually be useful for any of these kind of storage layouts, and you can just contribute it to any of those. There's also manual, which means just that. It doesn't do anything until you manually switch it over. And then there's also a hot spare, and that's very handy. For example, if I had a 2-way mirror, and one of the drives failed, but I also had a hot spare, Windows would immediately start to implement the hot spare and copy the data from the last good drive to the hot spare and put me back in a fully running situation very, very quickly. And that would not require any manual intervention. So again, also the replacement disks, if I didn't have a hot spare and I found out that the drive went bad, I saw an error message or something and I decided to replace it, then it's going to automatically sync. All I have to really do is to just replace that disk and make it available, and then it's going to sync itself. The hot spare, like I said, also will automatically sync. Okay, so how do you access all of this? Well, you go to File and Storage Services. It's directly in Server Manager already here. And you can see here we've got the server itself. If I had other servers that I wanted to be able to manage here, we could add those in as well if we wanted to. Here we can look at the volumes that we currently have. These are already the formatted volumes that have my operating system and my system and my boot files. Here are the actual disks that I have. This just gives me one view of the physical disks, as you can see right here. This disk right up here is what stores my operating system and has these 2 volumes. Okay, and you can see them just in a different view there, just a different way of looking at it. Here, these disks are totally raw. They don't really have anything on them. There's no volumes, there's no partitions, nothing. And then there's my storage pools, which is primarily where I like working from. Here you can see that I've got various disks down here. I've got 4 inserted that I'm not using yet. These are part of what we call my primordial pool. Kind of like the word means. It means that there's nothing refined or nothing configured about them. It's just raw disks in this case. Now let's say that I want to make these 3 disks part of a 3-way mirror. Well, I really like this new technology from Microsoft using a 3-way mirror. I don't think they really invented it, but anyway, I'm a big fan of the 3-way mirror. So let's go ahead and right-click here to choose a new storage pool, and click on Next, and I'll just call this my 3-way mirror. And then we click on Next, and we've got our disks right here. Okay. Now once we've got these up here, we want these to be automatic if we want them to be part of the mirror. Otherwise, we could choose this one, for example, and say, hey, you know what? On second thought, yeah, I got 3 disks for my 3-way mirror, but wouldn't it be nice to have a hot spare for this last one? Sure. So we'll click on Next. Once we've done that, we can go ahead and then look at a summary of what it's about to do. Okay. Then we'll go ahead and create our 3-way mirror. Now, in reality, this storage space, it's not technically a 3-way mirror quite yet. In order to make it a 3-way mirror, I have to create a virtual disk. This is just from my reference. I call it a 3-way mirror, so I know what I was using this storage pool for here, or the storage space for. So I'll now right-click here to choose New Virtual Disk, and then start the wizard. I'm going to use this storage pool, again, which I just created, okay, and then click on Next. I'll call this I'm running out of words here. Just call it the 3-way mirror volume. How about that? Then we'll click on Next. And of course, you can see here it's going to be mirrored, duplicated on 2 or 3, in this case 3 disks. All right. I could have also chosen simple or parity. But in our case, of course, I want to use it as a mirror. Then I'll click on Next. And here's where I can make it fixed or thin. This is very cool. I can just click on Next here, and I can say I want the virtual disk size to start off at, let's just make it 10 gigabytes. And then it will grow as necessary. Then I'll click on Next, and that's pretty much it. Now we'll go ahead and create this and let it do its thing. So then I'll close that up, and we'll now see that we have a new volume wizard. Okay, so now we've got our virtual disk down here, but it doesn't have any partitions or anything. Okay, so we now have to be able to work with this in order to make it accessible. So we're going to work with this server, this disk, click on Next. Here's the volume size, which can grow over time. Now we get to the point where we'll actually be able to access it. I'm going to give it drive M just for mirror, just to make it more intuitive there. Then we'll click on Next, and we'll call this, 3 mirror. Okay. Then that's pretty much it. I can click on Next here and create. And once this is completed, we'll then see that we can go to Windows Explorer and access it by drive letter. So we'll click on Close, open this up, and now finally I've got my 3 mirror thing right here. Okay, and I can just start creating files on this. Alright, so skipping ahead here, I've done something where I've put some data on that drive. Let's say I've put this file on here. This is a picture I took in the Grand Tetons. Can't remember when it was. I'm going to guess it's September 25th of 2009. Anyway, this is the photograph, and it's not really my favorite photograph because they were doing controlled burns. There's a lot of smoke in the air, so it wasn't my favorite, but hold on a second. Wait a minute. I got to zoom in on something here. Saw a dark spot down here. I don't know, I'm just kind of fiddling around. But anyway, I thought I saw something here. There it is! It's a moose! I don't know if you can see that. I might have to zoom in even more. But anyway, so this is an important picture to me, let's say, because I just found a moose. I don't want to ever lose that. So I've decided to implement this RAID 3 solution. That's the whole reason for doing this, people, for moments like this. So I'm going to go ahead and close that up, but I want to save that file in case something ever goes wrong. So now what I'm going to do is I'm going to go back over here to Hyper-V. This is actually my Hyper-V server where I'm hosting the machine we just looked at, which is my domain controller. And I'm going to go into the settings. This is one of the few settings you can't actually fiddle with while the system is up and live. Now, this is drive 1, drive 2, drive 3, and drive 4, but it doesn't really correlate necessarily to the number 1, 2, 3, and 4 in the operating system. For some reason, it scrambles these, so I really don't know which one is which right now. So I'm going to try not to delete my hot spare, but I might do it. Regardless, it doesn't really matter because we'll still be able to get this going. So I'm just going to say, let's move 3 and see which one that is. Okay, and I'll click on Apply. I'm going to go ahead and continue. It's telling me I might corrupt my virtual machine, but hey, I live dangerously, folks. So we'll go back over here now, and as we go back into this interface, we'll see if it gives us any errors or anything like that. It should tell us if it's noticed that something's gone wrong with one of these disks. I may have to refresh it. Alright then, so I paused recording to let this do its thing, and I went to the kitchen to get a drink of water and stuff, and when I came back, it had already done something I wanted to show you. But remember that one of these was a hot spare? Well, it did it by itself, and it's now not a hot spare. It's now part of the 3-way mirror. And you can see that the virtual disk itself is just fine. There's no problems with it. The only reason why I'm still getting some yellow triangles is because this disk still doesn't know anything about it. It's just, it's gone. So I'm just going to permanently remove that one. Okay, and maybe I'll replace it later with a new hot spare, for example. And then once that's been gone, then we'll see that we get rid of our yellow exclamation points as well. Also, before we conclude here, I want to clarify the whole process here once again, just kind of review this. We take physical disks and we use them to create storage pools. Once we have a storage pool, we can then create virtual disks, which is the stage at which we can actually start to put data on those disks. Alright, then I went back into Windows Explorer here just to confirm that my data is still there. And there's the photograph that I showed you earlier. Here it is. I zoomed back in again because I'm so excited to see that moose right there, even though it's very, very far away. Oh, and look, I think there's little geese over here. Anyway, so the picture looks fine, and we have not lost any data because we had 3-way mirroring turned on. In this nugget, we took a look at configuring local storage. We looked at basic and dynamic disks. Remember, basic disks are what we've kind of always worked with, but dynamic disks allow us to create dynamic volumes. That's what allows us to have mirroring and things like stripe set with parity or RAID 5 and stuff like that. We took a look at file systems like NTFS as well as FAT and FAT32. And then we also looked at the resilient file system, which is a very exciting new file system. Gives us a great deal of recoverability and capability there. We took a look at how to create our own VHDs. Remember, you can do that in disk management. We also took a look at how to mount VHDs, which could be any of those that you have created, or you can also work with a virtual machines VHD. A very handy thing to do. We took a look at storage spaces, which is probably the most powerful and flexible new feature relating to storage that Windows Server 2012 has to offer. And Windows 8 also offers kind of a subset of storage spaces available as well. Well, I hope this has been informative for you, and I'd like to thank you for viewing.